Question number 41. A vessel of uniform rectangular cross-section with height h0 and mass capital M contains a certain amount of oil having mass simple m and density rho oil as shown in the figure. The vessel floats vertically in water of density rho W. Rho W is greater than rho oil with height h1 underwater. A certain volume of oil is now replaced by an equal volume of water. If the maximum volume of oil that can be replaced while keeping the vessel floating is V and the initial volume of oil is V0, then the ratio V over V0 is given by. Assume that at the end of the process there is a certain amount of oil left in the vessel. V0 rho oil G is the initial oil mass. We can subtract we can add used water volume V used water mass V rho WG, and we have to subtract removed oil mass. Removed oil mass is V rho oil G. This is the change of volume, change of weight. Change of weight should be equals to change of upcast. We can get change of upcast h0 minus h rho W G. Now we can cancel out all G terms. We can write, we have to get the ratio between V and V0. Then I will subject V times rho W minus rho oil should be equals to h0 minus h times rho W. You have to bring this part to the right hand side, minus V0 rho naught. V times rho W minus rho naught, h0 minus h1 rho W. We know that this is the simple M value. Simple M means mass of initial oil volume. Now we can divide those terms by V0. I will bring this change of density, difference of density to the right hand side. h0 minus h1 rho W minus M divided by rho W minus rho naught. Now we have to divide it by rho naught to get the ratio. Sorry, V0 to get the ratio. I will divide this side also by V0. V0 is the initial oil volume. Now initial volume, oil volume is they have given mass h0 minus h1 rho W minus simple M divided by rho W minus rho naught. V0 is the initial oil volume. We know that density equals mass divided by volume. Mass is density into volume. Then we can write density rho naught mass divided by volume. Then volume mass divided by density. Then we can substitute V naught, mass divided by density, mass divided by density, density rho I. Now we can try to simplify it. H naught rho W. It's going to be more carry 1042, an object in the shape of truncated, located solid sphere of radius r is kept at the bottom of the tank as shown in the figure. The distance from the center of the sphere to the bottom of the tank L. Tank is now slowly filled with water. Assume that the sphere is fixed to the bottom of the tank so that its bottom surface does not get wet. The variation of the vertical upward force F exerted on the object by the water with the height of water is best represented by. It is like this. We know that when increasing H value from 0 to this level means center level, the increasement of immersed volume of this sphere is increasing with time. The change of immersed volume is increasing with time. Therefore, you know that upthrust is V rho G, V is the immersed volume. Immersed volume is increasing with time. Then it should be starting like this. Up to L. After that, from this side to this side, the increasement is reducing with time. Therefore, it should be like this. Up to 2L. And after that, there is a constant upward force. Then we can get second answer is correct answer for the question number 42. We have used V rho G. V means immersed height. We have to consider change of immersed height with simple HI. Then 43, a glass of fresh orange solution of volume 500 cubic centimeters contains a few orange seeds at its bottom. It was observed that the seeds just began to float at the bottom when 10 grams of sugar was dissolved in the solution. Assume that the addition of sugar does not alter the volume of the solution. If the density of orange solution before adding sugar was 1000, then density of orange seeds in kilogram per cubic meter is approximately equal to. Now we know that when starting to float, an object in water or any other liquid, density of object should be equal to density of liquid. Therefore, we have to find the final density of the liquid. It is the density of orange seeds. When finding final density, we know that density equals to mass divided by volume. When considering mass, the initial mass is initial density of water, rho 1 into density equals mass divided by volume, mass equals rho v into initial volume. Plus, now we have added 10 grams of sugar. 10 grams means 0.001 kilogram. I will use this 10 into 10 to the power minus 3. 10 grams. This is the total mass. We have to divide by total volume. They have given that there is no volume change. No volume change. Therefore, we have to divide by V1 again. Density of initial water solution 1000. It is given in the question. Volume is 500 cubic centimeters. We have to convert it to cubic meters. When converting centimeters to meters, we have to put 10 to the power minus 2. Now cubic centimeters, then we have to substitute with third power, 10 to the power minus 6. This is the volume. Then plus 10 into 10 to the power minus 3. 10 to the power minus 2. Divide by volume is same value, 500 cubic centimeters. 1, 2, 3, 4, 5. We can cancel out 5 terms, 10 to the power minus 1. Then 0.5 minus 10 to the power minus 2 is 10 to 0.01. Divide by 5 into 10 to the power minus 4. Then 10 minus 1, 9. 4 minus 0, 4. 0.49 divided by 5 into 10 to the power 4. We have to divide by 5. 49 divided by 5. Sorry, we have to add it. 0.51. Then 5100 divided by 5. 1020. Then answer is 1 for the question number 43. 44. A solid block of metal of volume 1 cubic meter and density 8 into 10 to the power 3 placed at the bottom of a lake. What is the volume of the helium filled balloon connected as shown in the figure to make the block just float at the bottom of lake? Neglect the mass of balloon with helium. We have to neglect the mass of balloon with helium. It means we can consider that weight of this object mg should be equal to upthrust, total upthrust. When considering weight, they have given that density is 8 into 10 to the power 3. We know that density into volume 8 into 10 to the power 3 means 8000 into 1 cubic meter. It is the volume of the object. Product of these two terms should be mass of the object, and we have to multiply by g to get the total weight. We can neglect the weight of the helium and balloon. Then it should be equal to upthrust to float the object. Upthrust is V rho g. We can cancel out g term. 8000 equals to, when considering volume, we have to consider there are two parts of volume. First one is volume of block 1 cubic meter plus second one is helium volume. We have to find it. I will consider it as the helium volume. V1. Rho is density of water. Density of water is 1000. Now we can cancel out 1000. V1 is 7 cubic meters. First one is the answer for question number 44. Then 45. Part of huge man-made garbage dump on a large marshy and suddenly there are some spelling mistakes. Collapse and shake sands ejecting nearby houses up, which had been built on the marshy land. Which of the following physics principles that you have learned is most suitable to understand the ejecting the houses up? We know that when considering the garbage dump is suddenly collapsed and sank, then houses are floating up. We know that we can use the Pascal's principle because of the pressure due to garbage dump should be equally divided among nearby houses, and it is the cost to ejecting houses up. Then we can get fourth one is the answer for question number 45. Then 46. Three tanks A, B and C open at the top are initially filled with water to levels as shown in figure. They provide water at very slow speed to an outlet where static conditions could be applied. We can consider there is a static condition. There is no water flow. The two valves V1 and V2 allow the water to flow only downwards when pressure above the valve is greater than the pressure below the valve. When the system is put into operation with the initial conditions shown in the figure, which of the following statements best describe the subsequent operation of system? Only C will contribute to flow at the outlet. Now we can't get it. We know that when V1 and V2 valves are open, there is a flow through all A, B, C tanks. Initially C starts to contribute to flow at the outlet, followed by B and then A is succession. Yes, it is correct. Then I will explain it. There are three heights in A, B and C. The maximum water height is in the C tank, then second B, finally C. Finally A. C, B, A. When these two valves V2 and V1 are opened, for the initial situation, the pressure of this point due to C is greater than pressure of this point because of there is a maximum height. Therefore, water will not flow due to B and A for the initial condition. This pressure is greater than this one, pressure of this point. But Due to this flow, when decreasing this height to this level, can be also starting to out water, and then water level of all tanks, all three tanks becomes to this level, and then A is starting to give water to the outlet. Then second answer is correct for the question number 46. 47. Figure shows the objects A, B, C, which are made using three uniform wooden cubes of identical dimensions made out the same material, and three identical uniform metal cubes. In A and B metal cubes are grooved into the top and bottom of the wooden cubes respectively. In C, metal cube is embedded in the wooden cube as shown in the figure. The three objects A, B, C now slowly lowered without changing their orientation and made to float vertically in pool of water. If the depth of which wooden cube are immersed in water, HA, HB and HC respectively, which of the following relationship is true? We know that there is a common weight for all three given conditions. Therefore, weight is constant, but when considering D situation means metal block is in lower surface. Therefore, there is an upthrust to the metal surface. Then, immersed height of this situation is the smallest one. Then HB should be the smallest value. But when considering first situation, it is like this. Metal volume is in upper surface. Therefore, there is no an upthrust on this one. Therefore, HA should be, immersed height of A should be greater than HB. When considering third part, now metal block is within this one. It should be a medium value, a value between these two terms. Then HA should be greater, HC and HB should be the smallest value. Then answer is 5 for the question number 47. Then 48. A piece of metal is attached to the rectangular wooden block that floats in water as shown in the figure. 50% of the volume of wooden block is submerged in water. The metal piece and wooden block have same masses. If the wooden block with the metal piece is flipped upside down, what could be the percentage of volume of wooden block submerged in water? For the given condition, we can use, it is like this. Mass of this part and this part equal. It is given in the question. Then, if the immersed volume is V, we can write now V rho G, upthrust should be equal to 2mg. It is the immersed, V1 is the immersed volume for first condition. When it is upright down, it should be like this. Again, 2m should be equals to, now immersed height to immersed volume of this one V2. We can write V2 plus this one V rho. Then we can compare two equations. We know that density of metal is greater than density of wood. Therefore, this volume is a smaller one. Then the upthrust on the metal block is a small value. Upthrust on wooden block is a greater value. Then we can use new immersed volume is less than this immersed volume. We can get slightly smaller than 50%. Then first one is the correct answer for question number 48. 49. Water and coconut oil are poured into the two limbs of a U-tube as shown in the figure. Assume that a water-oil interface at the middle of the tube and it is vertical. Rho W density of water, rho oil density of oil. Consider the following expression about this situation. Pressure at point P equals pressure at Q. Yes, we know that if there is an equilibrium like this, the interface is at this place, then pressure of P equals to pressure of Q. A is correct. B. HL rho W. HL rho W. H1 is this height. We can write H1 rho W G should be equals to coconut oil height H2, H2 rho oil G. We can cancel out G term, then statement B also correct. C. H3 height. H3 height is this height. H3 rho W. We can write pressure at this place. H3 rho W. Pressure due to water. This water column should be equals to H4 rho W is given. But we know that when considering this point, there is no movement to right hand direction or left hand direction. Therefore, these pressures are equal. It is correct. But when considering this layer, this point is in water and this point is in coconut oil. If we are using Pascal principle, it is compulsory 2 points should be lie in same liquid. Now there are different fluids, then statement C is incorrect. Only A and B correct. Then third one is the correct answer for question number 49. 50. A copper block is hung over the beaker of water by spring balance as shown in figure. Consider the following positions where the beaker of water is slowly rise upwards. Position 1. The block is partially submerged. 2. The block is completely submerged. 3. Block is on the bottom surface of the beaker. The buoyant force means upthrust, and the reading of the balance with respect to the positions 1, 2, 3 are given by B1, B2, B3 and W1, W2, W3 respectively. Which of the following is correct? We know that buoyant force, it means upthrust. Upthrust is increasing when submerging object. Then B1 is a small value. B2 and B3 should be same because of when considering B2 and B3 situations, the block is completely immersed in water. And when considering spin balance reading, we can get the maximum reading is W1. It is directly weight of the, it is equal to the weight of the given copper block. And when immersing it in water, W2 is smaller than W1 because of there is an upthrust on the object. For the final situation, there is a reaction and upthrust for the object. There is a reaction due to bottom surface. Then W3 is the smallest value. Then answer 5 is correct for the question number 50.